Okay, so your chemistry paper haven't finished. So let we see your question. Okay, how was the difficulty level of your question? So let me start it to analyze from your essay type question. So in your essay type question, there are three questions from the three chemistries. One from the physical chemistry and one from the inorganic chemistry and another from the organic chemistry. So let me start from your physical chemistry. In your physical chemistry part, the question number is 32. That question is from the solid state here. Okay, so let me read the question here. An element having atomic mass 80 grams per mole at a phase center cubic structure. Calculate the number of unit cell present in 8 gram of the element. So this question, okay, not much difficulty, not much easy. So it's the average question that's related to your concept plus logic. Okay, those students who are very strong concept and logic, I think they could answer this question very easily. But here I give you the how is the keys of this answer, right? Okay, now number first one, let we think about what is the knowledge required to answer this question. Here this question is related to number of unit cell and the number of atoms. So I write here, this is the first key knowledge, that is the relation between number of unit cell and number of atoms. Here, if you know the number of atoms, we can find out the number of unit cell. This is the logic. Okay, you should remember. Now here, so in the given question, okay, how to know the number of atoms? Here the very important concept we applied here, that's from the mole concept. In the mole concept, you know, I write mole concept. So by using the mole concept, we can calculate the number of atoms from the given number of the moles or from the given mass of 1 mole of the substance here. See, look at in the question, atomic mass of the element 80 grams per mole. So I write here atomic mass. So what does mean mass of 1 mole of atom? So what is the atomic mass? That is 80 grams per mole, you know, right? What it means that, okay, so the number of atoms, okay, we are going to calculate from the atomic mass. So as we know that, okay, so number of atom in 1 mole. Okay, so this is 1 mole. Okay, how many number of atoms? You know from the mole concept, the number of atoms is 1 mole, that is 6.023 into 10 to the power 23 number of atoms. Now again, atomic mass is the mass of 1 mole of the atoms. So what is the mass of the 1 mole of atom? That is number of atoms in, so that is the atomic mass. Let me write atomic mass of the atoms, that is how much? 80 grams per mole. So how much is there? It's same as the number 6.023 into 10 to the power 23. Okay, now we are going to calculate the number of atoms in 1 gram. Okay, let me write number of atom in, so here gram is given here 8 gram. In 8 gram of the element, how many number of atoms? That is in 8 gram. So we know the calculation, 6.023 into 10 to the power 23 divided by 80 grams per mole, then into 8 grams. Okay, gram can be cancelled. This is the per mole can be cancelled. So after we calculation, so now here this should be 10 divided by 6 equal to 0.6023 into 10 to the power 23, right? That means, so we can write this one, or we can write 6.023 into 10 to the power 22, right? Now, this is the number of atoms in a gram. If you know the number of atoms, so let me start to calculate the number of the unit cell here. How to calculate the number of the unit cell? See, in the questions given here, so here this element adds up. What is the structure of the key crystal? That is the face-centered cubic structure. That means FCC. Now, if the elements add up the FCC structure, so what is the number of atom per unit cell? You know, number of atom per unit cell. That means in one unit cell, how many number of atoms? So we know that is the 4. So we can just replace that, okay, in the 4 atoms, okay. How many number of unit cell? In 4 atoms, okay. So number of unit cell, how many there? 1. That means in 1 unit cell the number of atoms is 4. That means in 4 atoms, how many unit cell? That is the 1. So already we know the number of the atoms in a gram. So therefore, what is the answer here? In, so 6.023 into 10 to the power 23. So that's 22. Should be 22. So the number of unit cell, how many should be there? How many number of unit cell? That means 1 divided by 4 into 6.023 into 10 to the power 22. That is the number of the unit cell. So if we divided this, so how much should be? That would be the 1.5 something there, okay. 1.5 into 10 to the power 22 atom, so unit cells. This will be the answer of that question, alright. So this question is carried 3 marks. So you have to find out all these things. So the correct answer should be 1.5 into 10 to the power 22 unit cells. Understand? Right. So these questions carried the 3 marks. One more questions there. That question I show you here. That question I show you, that is number B. Sodium chloride crystal becomes yellowish when heated with sodium vapor. Explain what effect would be observed on the density of the crystal. Right. So this question, okay, that's from the defect of the solid. That means solid defect. So in our solid defect, right, we have 2 different types of defect. One is the stoichiometric defect, another is the non-stoichiometric defect. In stoichiometric defect, we discuss about 2 different types of the defect. One is the Schottky defect. Number 2 is the Frankel defect. So in Schottky defect, equal number of the cations and anions are mixing from their lattice side. I mean that their interstices. I mean the lattice side. So that types of the defect we call the Schottky defect. Then in a Frankel defect, one of the cation is mixing from their lattice side and occupy the interstitial side. So these 2 difference. What about the density here? In the Schottky defect, right, since the number of the cations and anions are missing from their lattice side, so the number of the ions decrease as well as the mass of the crystal decrease. the volume will remain unchanged, so the density will be decreased. Right. That in the case of the Frankel defect, no ion missing. That ion is okay. Normally occupied in their interstitial site. That means number of the ions remain unchanged, the mass remain unchanged, volume remain unchanged, density does not keep changing. Means density remain unchanged. But related to this question here, sodium chloride vapors, sodium vapors, okay. So when heated with the sodium vapor here, in the sodium chloride, okay, the sodium vapor, okay, so diffuse on the surface of the sodium chloride. That sodium chloride, okay, the sodium metal, so that sodium metal, so okay, combined with the chloride ion is already diffused on the surface of the crystal, and so this sodium, okay, can get changed into the sodium ion and electron is there, right? So that sodium ion combine with the chloride ion and form the sodium chloride on the surface, right? But these electrons, okay, so this chloride ion, so it's diffusing from the surface of the crystal and combine to form the, okay, sodium chloride. That's okay, the sodium chloride ion, so the place where the chloride ions present, so that place is now becoming empty. That vacancy what we call anionic vacancy. So compared to the number of the negative charge and the number of the positive charge present, so this number of the positive charge is higher than the number of the negative charge. Therefore, these types of the defect we call metal axis defect due to anion vacancies. So how this defect impart the colors? See, this electron is trapped into the anion vacancy. That electrons, when exposed under the sunlight, this electron is excited, okay, in the higher energy level. That electrons, okay, impart the colors. Now here, see, as per the number of the ions counted, right, compared to this, one of the electrolyte sites remain vacant. So since the vacancy, I mean the holes remain there, so the crystal, the number of the ions decrease, okay, and the mass of the crystal also decrease, so the density obviously decreases. This should be the answer of that question. Okay, so these types of the defect is related to the Schottky defect, right? Understand? So that will be the keys of that your answer, right? Then next question. So the another solid state question, that is the OR question. So here is the given, okay. So that question, an alloy of 3A metal ABC has the A atoms forming CCP lattice, while B atoms occupy the A center and C atom occupy the body center. Establish the formula of the alloy. So here, as I told you, this question is not the level of the difficulty. That means, so every students who understand about the derivation or determination of the empirical formula of the compound, so I think they could understand how this question could be answered, right? See here, we are going to calculate the number of the elements per unit cell. As we know here, the answer key what we should remember here. See, in this compound, I mean the alloy, so what are the elements, what are the metals given here? A, B, C. I write A, B, C. Now here, where A occupied, so A present at the CCP. That means, okay, so these A's are arranging in cubic close packing likewise. Now B occupied a center, right? Then C occupied the body center. So now when we write the formula of the compound, so we should know the what is the number of the A, what is the number of the B, what is the number of C. So what will be the formula of this compound? Suppose I write a formula here, A, B, C. So what is the number of the A, what is the number of the B, what is the number of the C? We have to calculate the X, Y and Z. Now here, suppose the number of the A in CCP, here number of the A in CCP, that means I write A, okay. So when the number of the A, I suppose here 1, okay, but B occupied a center in an unit cell. How many S centers there? 12 A centers. So the atoms or the metals occupied one of the A centers. How many unit cell can be shared? That means number of the B. So number of the B can be shared at how many S center? 12. Then one of the atom or metal which is present at the S center can be shared with the 4 unit cell. That means how many numbers there? 3. Then number C, that means C. What is the C? Where is C occupied? In the body center. In an unit cell, how many body center? That is the 1. So the atoms or metals present at the body centers, okay, do not share with the another unit cells. Therefore, how many numbers there? 1. So what is the number of A? That is the 1. What is the number of the B? That is the 3. What is the number of the C? That is the 1. So using this number, what is the formula? So that should be the formula A, B, 3, C. This should be the answer of that question, right? The next question, the D part, that is written here. Germanium is an intrinsic semiconductor. How can you increase its conductivity? Right, okay. So, during our class, okay, we or your teachers may not explain about the intrinsic semiconductor because this topic is majorly related to your physics, right? So in our chemistry we should know that what is the semiconductor and how many types of semiconductor. So in our semiconductor we classify into two. One is the intrinsic semiconductor, another is the extrinsic semiconductor, right? Some material in their pure state, okay, they are considered as an insulator, but that insulator we can convert it into the semiconductor. How can convert it into the semiconductors? So there are different options. One option is, right, that is the thermal effect. So on heating the any insulator, that substance can be converted into the semiconductor, right? So these types of the semiconductor means intrinsic semiconductor is related to thermal effect. Don't forget. That means it depends on the temperature, right? Then extrinsic semiconductor is related to the substance which can dop or which can mix with the our insulator. That is what we call impurity defect. This is the thermal defect or thermal effect. You can say thermal defect or thermal effect, right? So here, intrinsic semiconductor is related to thermal defect. That means their conductivity is increased. Their conductivity is increased with increased temperature. That means conductivity increase with increased temperature. Right. So this is the answer of that question. So here they give you 2 marks. Okay. Then here in your inorganic chemistry portion here, so it's a very easy question for you. The number 1 is the manufacture of ammonia by Haber process, very common, and preparation of the xenon trioxide, it's also very common. So it's the very general question, everybody could understand and could write. So then the another ore is the manufacture of sulfuric acid by contact process. Every student they prepare for this question. So I'm sure that you could answer this question. How is PCl3 prepared? So that is also very clearly written in your textbook. How SAP does it adopt? That I think it's very easy to answer. So now here, so these 2 questions. So I hope you could answer what are the keys, so you could find out very easily. But in the organic chemistry portion, right? So what the questions given here? Let me read the question. A compound A. So what the molecular formula C2O4, C2H4O is produced by the partial oxidation of ethanol with PCC. This is the oxidizing agent. It reacts with hydrogen cyanide to produce the compound C, a compound B, which on hydrolysis form an optically active compound C. Identified A, B, C and write the reaction. So for that, so it carried 3 marks. The number 2 question is the illustrate Hall-Bohr-Jelinski reaction of 2-methyl propanoic acid. Now I give you the question. I give you the keys of this. Number 1, the compound C2H4 oxygen. Here let me write what are the options. Look at in the given organic compounds, here the compound containing oxygen, what are the compound possible? The compound, organic compound containing 1 oxygen, it may be alcohol, it may be ether, then it may be aldehyde, or it may be ketone. These 4 compounds may be possible here. See, but in the questions given here, so this is the compound produced by the partial oxidation of ethanol. Therefore, this given compound, I think it's not alcohol, because this is the compound formed by the oxidation of ethanol. So these compounds may not be ethanol. If this compound is not ethanol, so this molecular formula is not related to ether, because alcohol and ethers are functional isomer. Then, so the only 2 points remain there. One may be the aldehyde or maybe ketones, right? So here, in this compound, how many carbons there? 2 carbons. Suppose this compound is either aldehyde or ketones, right? So this compounds containing the 2 carbons, so that compounds may not possible the ketone, because ketone always consists of 3 carbons. So this carbon only 2, so that may not be possible then our ketone. Only the compound should be the aldehyde, right? So, and second thing is that it reacts with hydrogen cyanide. Hydrogen cyanide is the reagent which can react only the aldehyde or ketones. Now we confirm that this compound is aldehyde, right? So how is this compound formed? Let me start to write the aldehyde. So here ethanol. How is ethanol? So CH3, CH2, OH, right? So this is the ethanol. As we know the categorically, this is the primary alcohol. So when primary alcohol undergo oxidation, what should be the compound? So as we know, this should be the aldehyde. How will write the aldehyde? So this part can be converted into the form of aldehyde functional group. So we write like this. See, count the number of the carbons, C2. How many hydrogen here? 4. Then how many oxygen here? Okay. So this is the compound A, right? The number 2. If this compound reacts with hydrogen cyanide, as we learn in your organic chemistry, okay? So when the aldehyde or ketone reacts with hydrogen cyanide, right? What is the type of the reaction? Is nucleophilic addition reaction. Here, one is H plus, another is Cn minus, right? So now here, this H plus is combined with the oxygen. This double bond becomes single bond, and this Cn minus is bonded with the carbon. So what will be the product? CH3, COH, again H. Then now here it's from the Cn. So what is the name of this compound? The name of the compound is, so it was the ethanol. So this is the name of the compound is ethanol cyanohydrin. So this is the key compound B. Then number next. This cyanohydrin, okay, form an optically active compound on hydrolysis. As we know, this is the cyanohydrin. Let me write here this cyanohydrin right here. So on hydrolysis, let me write water. See, as we learned that any compound containing the Cn group, right? That compound undergo hydrolysis, this Cn, so it converted into the carboxylic acid. So how will I write this answer? That will be the OH, here will be the H, then this part we write COOH. That should be the answer C. See, this answer C as given here, optically active compound. How the compound is optically active? See, here you find out a carbon. This carbon, this carbon, and this carbon. How many carbons there? 3 carbons are there. In these 3 carbon, first carbon is surrounded by 3 hydrogen. The last carbon is surrounded with the 2 oxygen. That means, okay, so here I will write this 2 oxygen, 1 OH, right? So these carbons we don't consider the asymmetry. Then now here this carbon. See, one group is here, another group is here, one atom of the hydrogen here, another group is here. All these 4 groups are different. That carbons we call asymmetric carbon, right? That compounds, okay, poses the chiral. That means chirality. So this is the chiral carbon. Compound containing the chiral carbon or asymmetric carbon, that compounds are optically active. Optically active. So these are the keys of this question, right? Okay. Next, Hall-Bohlert-Zielinski reaction. Hall-Bohlert-Zielinski reaction, we know that is the replacement of alpha hydrogen, okay, by the chlorine atoms. See, that is what is the, okay, halogenation. Okay, here, what is the compound given? In this reaction, that means Hall-Bohlert-Zielinski reaction, what is the compounds given? 2-methyl propanoic acid. Propane, how many carbons there? 3 carbons. So the compound is acid, write it like this. Now here 2-methyl, here 1, 2. This is the 2. So methyl here. So here CH3. So here how many bonds already there? 3. So 1 hydrogen should be here, right? Now here, this compounds what we call 2-methyl propanoic acid. Here, this is the functioning group. So the next carbon we call alpha carbon, right? The hydrogens present at the alpha carbon we call alpha hydrogen here. How many alpha hydrogen here? That is the one alpha hydrogen. Now, so this is not alpha carbon, this is not alpha carbon. So we don't consider this hydrogen, we don't consider this hydrogen. So these compounds when reacts with the chlorine, let me write the chlorine as a halogen. So in the presence of this sunlight, right? So this chlorine, one of the chlorines replace this hydrogen. Now, so what will be the products we found here, right? So here this will be chlorine, so the other remain unseen. This types of the reaction we call Hall-Bohr-Zielinski reaction. So what was the name of this compound? It's already given here, 2-methyl propanoic acid. What is the name of this compound? Is 2-methyl propanoic acid. So this is the answer of this question, right? Okay. Then we will another question, that is the OR question. So I show you here. So the last question is, an organic compound with molecular formula C5H10 oxygen exists in different isomeric structures. Identify the isomer which number 1 undergo Cannizzaro reaction, number 2 undergo haloform reaction. It gives a butanic acid. Number 3 is obtained by ozonolysis of 3,4-diethyl hexane 3-ene. So let me give you the hints of this question. Here, molecular formula of the compound is C5H10 oxygen. Now here, this as we discussed before, the previous question, the compound, organic compound containing the one oxygen. So what are the possible compounds? Might be alcohol, might be ether, might be aldehyde, or might be ketones. Here, the number of the carbon is 5. Here, in this question, so this given compound molecular formula, what type of the compound it should be related? Here, number 1 hints given, that is the Cannizzaro reaction. So Cannizzaro reaction is related to the compounds. Okay, what type of the compound? Either aldehyde or ketone. Number 1. So that aldehyde and ketones, okay, what should be the aldehyde and ketone undergo Cannizzaro reaction? That aldehyde and ketone should not have the alpha hydrogen, no alpha hydrogen. Now, so let us start to draw the in the form of the aldehyde or in the form of the ketones. Okay, that aldehyde and ketones, no alpha hydrogen, should not have the alpha hydrogen. So how do we write? Number 1, in the aldehyde and ketone, what the functioning group it should be common? This functioning group should be common, right? So if we write here, one I write a hydrogen, suppose that is the hydrogen. If we write a hydrogen, that is belongs to aldehyde. Then how many carbons there? 5 carbons. If I write this is the functioning group, the next carbon we call as we know alpha carbon, right? At that carbon should not write the hydrogen. So how many bonds should be there? 4 bonds. So 1 only bond, 3 bonds should be there. Don't write any hydrogen. This remaining bond, it should be right there with the number of the carbons given. How many carbons? 1, 2. So 3 more here. 1, 2, 3. So that will be the hydrogen. Here also be hydrogen. Here should be hydrogen. That's we count the number of hydrogen. Okay, 3, 3, 3, 9 and a 10. That means is 10. So 1 oxygen. Okay, 5 number of the carbon. So these compounds, okay, there's no any alpha hydrogen. So this is the one of the isomer. So this isomers, this compound, this isomers containing no alpha hydrogen undergo Cannizzaro reaction. This is the first answer. right? So if you write a ketone, that means, okay, when you write a ketone, so let me write a ketone. So ketone should be the, okay, in between the two carbon, it should be the, okay, this functional group C double bond oxygen. Okay. Now here, how many hydrogen, how many carbons there? Okay, 5 carbon. 1, 2, 3. Let me write one more carbon here. Let me write one more carbon here. So when we fill up the hydrogen, so it should be 3. It should be 3. Here it should be 3. So here it should be 1. See, this is the alpha carbon. This is the alpha carbon. If you write a ketone, so that ketone should have the alpha hydrogen. So that isomer is not possible. The Cannizzaro reaction. So our answer is this one. So what is the name of this compound? Let we write the name of this compound here. So compound belonging to the aldehyde. So let me start counting 1, 2, 3. Add 2, this 2 methyl. That means 2 dimethyl. How many carbons? Longest 3. That is the propanol. This is the name of this compound, right? The number 2 question is haloform reaction. So in our class we learn as the iodoform reaction. Okay, haloform reaction. The one of the example is the iodoform reaction. So in our haloform reaction, that compound also related to aldehyde or ketone. So the compound, I mean the aldehyde and ketones, okay, what type of aldehyde and ketones undergo haloform reaction? That aldehyde and ketone should contain this group. This group should be contained. So when you draw this isomer of the given molecular formula, that aldehyde and ketone should contain this part, right? How will I write? Let me write this one. So here we start to write this. Then how many carbon here? 5 carbon, 10 hydrogen, 1 oxygen here. So one of the, that means aldehyde or ketone should be present this. The remaining carbon, let me fill up here. So how many carbons here? 5. 1, 2, 3, 4, can be 5 here. So let me write a hydrogen, let me write a hydrogen, let me write a hydrogen. See, let me count the number of the hydrogen. 3, 5, 7, 10. So that equal number of this, number of carbon, number of hydrogen, number of oxygen. Another isomer we can write here. Same this group. So here these 3 carbon. Let me write like this. That also be possible. Right? So this isomer and this isomer, which one will be the correct answer of this question? Here, let me confirm this. Suppose this also can undergo haloform reaction because this compound also containing this. This compound also can undergo haloform reaction because this group is present. So, but either these two, which one will undergo the haloform reaction according to the question here. The question is give butanoic acid. So if this compound, let me take this one. Haloform reaction means reacts with halogen. So let me write iodine in presence of the sodium hydroxide. So this part, this CH3 part, okay, bonded with the C double bond oxygen, it should be converted into the iodoform. This should be converted into the iodoform. The remaining part, okay, so it's converted into the acid, I mean salt of the carboxylic acid. So what is this acid given? Butanoic acid. How will I write the butanoic acid? CH3, CH2. Let me start from here. CH2, CH2. Then now this part should be write as acid. So this is the butanoic acid. But if this one's undergo, so if this one undergo iodoform reaction, yes, this compound will form the same compound, but the remaining part, so that may not be butanoic acid. So that may write this is is not a butanoic acid, this is the propanoic acid. Therefore, this isomer is not possible. This should be this one, right? Understand? So this is the second answer of this question. The third question is, obtained, the isomer is obtained by ozonolysis of 3,4-dimethyl hextriene. This is the reductive ozonolysis. How this reaction is written? See, 3,4-diethyl hexane. Hex means 6 carbon. 1, 2, 3, 4, 5, 6. Where the double bonds present? At the 3. Alright, then add the 3 ethyl, C2 has 5, let me write, then 4, C2 has 5. So here I write CH3, CH2, no hydrogen, CH2, CH3. So reductive ozonolysis reacts with ozone followed by the zinc hydrolysis. Now here, so instead to write the full step of the reaction, so let me write it very quickly. So half of this, I cut it half of this. This remaining double bond, some part of the double bond we bonded with oxygen, some part of the oxygen bonded with the oxygen. So what is remaining here? CH3, CH2, C. That is the C which I show you here. That double bond which I cut it here, then I bonded with oxygen, and the remaining part is C2 has 5. Let me write C2 has 5, C2. Then has 5 means here will be 2, here will be 3. So that same part of this answer will be same part, because equal part of this we found it like this. Same part. This one same. So how many carbon here? 5 carbon. How many hydrogen here? 10 hydrogen. How many oxygen here? This is the given molecular formula. But now this isomer we found from the reductive ozonolysis of given this compound. Therefore, this is the third isomer. Understand? So these are the answer of this question. But here, so we have to write the reaction, how the reaction takes place, and we have to write the name of this compound. What is the name of this compound? 1, 2, 3, 4, 5. That means, okay, so at the 3, this K compound is a ketone. So what is the number of the carbon? Pentane double single bond and the 3-ONE. That means pentane 3-1. So this is the our answer of these questions of your essay types, right? So these are the keys. So you just compare your answer, what you have done. No doubt, if you write all these things, so you'll get a full marks, right? So 15 marks from your essay type question. So you just keep on, okay, remember how we'll do it on exam. All the best, right? Thank you very much.